Okay, welcome back. So we got x equals 9/4 and x equals 4/3 as solutions to our math. And it was a surprise because we were only expecting one solution, and we were expecting that solution to be between 2 and 3, which is here.
Yeah.
Right? Now, let's just check real quick. 9/4, what's the square root?
It's 3 halves.
So for 9/4, we get those 3 halves plus 9/4 plus 4.
16 fourths, so it's going to be 25 fourths.
Okay.
Which is 5 halves.
The square root of that is 5 halves.
Yeah.
Does this equal 2 times whatever the square root of 4 times 9/4, or 36/4, minus 5? So 36/4 minus 20/4 is
16 fourths
square root
is 4 halves.
4 halves, or
It's going to be 2 times 4 halves.
yeah, okay, 2 times 4 halves if you want, but 4 halves is also known as
2.
2. So does 3 halves plus 5 halves equal 4?
Yeah.
Yeah.
It's 8 halves.
Okay, so this is a solution. 4/3. I get the square root of 4/3. Plus, let's look at this one. 4/3 plus 4. So 4/3 plus 12/3 is
It's going to be it's 16 thirds.
square root of 16/3. Does this equal 2 times the square root of 16/3 minus 5?
Or 15 thirds.
So 16/3 minus 15/3 is?
1/3.
So we got the square root of 1/3 on the inside. Now we can simplify this side a little bit. How does this simplify?
That's 2 times the square root of a third.
2 times the square root of 1/3
And that's
plus
4 times the square root of a third.
4 times the square root of a third. And does this equal 2 times the square root of a third?
Nope.
Why not?
Because if this weren't here, then it would be equal.
Right, this is some number. We don't know what it is.
But we're adding something.
We're adding something to it and getting back the same number?
Nope.
Nope. That's not a solution. But interestingly, it would be a solution if it was this minus this. So if this was minus, if there was just a minus there,
then it would work.
then the 9/4 wouldn't be a solution and the 4/3 would be a solution. Right?
How can we get them to both be a solution?
Well, it's tough to get them to both be a solution because this is a solution of this equation and not a solution of that equation.
Yeah.
Okay? So we can't change our equation. I was just pointing out that if there was a negative there, this would have been a solution. Of course, that wouldn't have been. But see, the problem is, this is a fascinating problem, actually, and this is the first problem you've ever done where this problem came up. We liked to square both sides to get rid of the square roots. Square roots do have 2 solutions. When I'm looking at x squared equals 4, I get x equals plus 2 and x equals minus 2. So the square root of 4 can either be plus 2 or minus 2, and by just convention we say we're going to take the positive one. Because we want it to be a function, we don't want 2 outputs.
Yeah.
Okay. The problem is, when you square it, you're going to an equation like this. X squared equals 4. It has 2 solutions. One of them we ignored before. But just because we ignored it doesn't mean we go away. Like sometimes you try to ignore me, right? Did I go away?
No.
No. Too bad. So this solution, this negative square root, that really is living here, but we were just ignoring it, creeps into the solution when you start squaring things. You see how this minus 2 showed up over here
Yeah.
when we were ignoring it before? And so when you're performing this sort of algebra / arithmetic multiplication manipulation with square roots, sometimes these other solutions show up. And you have to check. When you get to the end, we saw, hey, wait a minute. There was one solution and another solution. This solution worked. The other solution didn't work. We didn't make any mistakes.
Yeah.
The solution just came as a result of all the squaring we did. It's very cool. It's very cool. And it's a great illustration of why you have to check your work. Previously, when you checked your work, if you made a mistake, we found that there was a mistake. Here, we didn't make any mistakes.
But we're still
the
gonna...
manipulations we were doing created another solution.
Yeah.
So you got to be very careful. All right?
Yep.
Good job. Good job with this. And this is a very challenging problem, but a very instructive problem.